Okay, class. Welcome to Success Chemistry exam class. We did chemical equilibrium yesterday, and today we want to look at heterogeneous equilibrium. When talking about heterogeneous equilibrium, we're talking about equilibrium that involves the species being in different phases of the reaction. Now, if you look at this first example, we have A plus B to give C. All components of this reaction are all gases. As you can see, G, gas, gas, gas. This kind of equilibrium that exists between, whereby all components of the reaction are in the same phase, is known as homogeneous equilibrium. When all the components of the reaction are in the same phase. Gas reacts with gas to give gas, homogeneous. But look at the second one, class, where you have solid reacts with gas to give liquid. This is not homogeneous, this is heterogeneous equilibrium. So heterogeneous equilibrium is the equilibrium that exists between components in different phases. Please take note. Now, I'm not going to note about components in different phases. When you start dealing with components in different phases, class, is what we call the activity. Activity of pure substance is one. Who are pure substances? Solids and liquid. Substances in their clean solid form or liquid form are referred to as pure. Who are unpure substances? Gases or substance in aqueous form. Class, these two people, their activity is not one. So if you see a reaction and you see AQ, you are not allowed to say the activity is one. The activity is not one. But if you just see S solid and you see L liquid, activity is what? One. Why is this information important? So we'll take you back to when we did homogeneous equilibrium. A plus B to give C, and they are all gases. When we are to write down their concentration equilibrium constants, we are going to say Kc usually is what? Concentration of the product C raised to the power of the coefficient small c divided by concentration of the reactant A raised to the power of the coefficient small times concentration of the reactant B raised to the power of the coefficient small b. You recall that this bracket stands for concentration. Now, this is the Kc for this reaction. But we are trying to write the Kc for this other reaction. Product is a liquid, so it's 1. You don't need to start saying concentration of C raised to power C. Everything leads to all over. One of the solid A is also what? Times concentration of B. So the Kc for this reaction, all in all, is just concentration of B raised to power what? B. Let's put small b, let's put small a, let's put small. Concentration of B raised to power what? So the whole Kc of this reaction is just 1 all over concentration of B raised to power what? For class, usually in the exam, they will not tell you that given that this reaction is an heterogeneous equilibrium, you will just find out that. Now, when we were solving before class, well, let's go back to homogeneous. Remember I told you, sorry, excuse me. Remember I told you that you can give me the concentration of this guy 0.1 m, right? 0.2 m, and let it be 0.5 concentration, right? And then you find the Kc of the reaction. That is what concentration of C, 0.5 raised to power, whatever, all over 0.1, right? Now in this kind of reaction, now you just know that they only give you one concentration. You say, how will I get Kc? They're not giving for this guy, not giving for this guy. What's happening? This is the wrong question. So they'll give you the same reaction and give you concentration of only the person that has an activity that is not one. So they'll give you concentration of B because B is an unpure substance. They won't give you for A and C. You'll now be wondering, someone that doesn't know that the question has now shifted to heterogeneous, will be wondering what's going on. Meanwhile, the B they gave you is enough to get your answer. But Kc is just 1 over the concentration of B raised to power the coefficient of, and you are done. And you are. So please take notes. Please take another aspect of heterogeneous equilibrium. Let's see if I have a question that we can use as an example. So class, we could even be given this. Class, you know water can exist in both liquid and gas, right? The reaction that involves water moving from liquid to gas is a very good example of heterogeneous equilibrium. Class, you could even be asked in the exam, if you give you a set of reactions, say, tick which of the following reactions is heterogeneous? Or you can write down an example of heterogeneous equilibrium reaction. The reaction is what? That is heterogeneous equilibrium. This is an example of heterogeneous equilibrium. Let me give you more examples. You know, we're using A and B. Let's give you real examples of heterogeneous equilibrium. So what textbook does when one is teaching is that it gives you a structure. You understand? Sometimes you might know something, but you might not know how to structure it to present to the students. But the textbook gives me a structure to follow. So I want to be teaching like without direction. So now, this is an example of heterogeneous equilibria. Another example of heterogeneous equilibria, we have mercury oxide. When mercury oxide decomposes to give mercury and oxygen. Mercury oxide is a solid. When it decomposes, it gives liquid and oxygen gas. So a solid broke down to give liquid and what? Gas, heterogeneous. So by the time you write down the KC, what must be the KC for this reaction? Only the product is mentioned, right? The KC for this reaction is concentration of, because Hg is 1, right? This 1 times, this is the only guy that has, so concentration of O2, but there's no coefficient here, so you are saying raised to power 1 there, right? Since there's no major number before oxygen, right? All over, this is a solid, all over what? 1. So the overall KC for this reaction is just concentration of oxygen. Concentration of what? The concentration of oxygen alone is enough to give you the KC for this reaction. Class, are you following? The concentration of oxygen alone in this full reaction, looking big, everything. And they only gave you this. Some say, what's going on here? But they're giving you enough to get the answer. Another good example is CaCO3. When it breaks down, it gives CaO plus CO2. S, gas. This is the only person that is unpure, right? So you can easily, I believe you can even write down the KC by yourself now, right? So this heterogeneous equilibrium. Please take notes. Class, please take notes. Now, the next one we want to look at is solubility equilibria. Solubility equilibria is a subtopic under heterogeneous equilibria. Solubility equilibria is a subtopic under what? Heterogeneous equilibria. So write down solubility equilibria. Solubility equilibria. Solubility equilibria. These are all examples of heterogeneous equilibria. Please, let's be fast in our writing. Class, for solubility equilibria, class, follow me. So I've covered in the solubility equilibria. Solubility equilibria. Class, this is equilibrium that exists between a salt in its undissolved state. Equilibrium that exists between a salt, write down. It's equilibrium that exists between a salt in its undissolved state and a salt in a dissolved state. Solubility that exists between a salt in its undissolved state and a salt in its dissolved state. It's equilibrium that exists between a salt in its undissolved state and a salt in its dissolved state. Solubility that exists between a salt in its undissolved state and a salt in its dissolved state. Class, look at this salt, NaCl. This salt is a solid, class. When it dissolves into its component ion Na plus Cl minus. As soon as the salt dissolves, class, it no longer is now in aqueous form. It's now in what? But class, there's equilibrium that exists between the undissolved. So when the salt is a solid, it has not dissolved, has not yet dissolved, right? So this is the undissolved part of the salt. This is the undissolved. As soon as the salt is now in aqueous form, it's now dissolved. It's now what? So class, for equilibrium to exist, the rate of dissolution must be equal to the rate of precipitation. Class, follow me. Class, when this NaCl is breaking down to Na plus and Cl minus, do not forget that for a reversible reaction, as this guy is going to this guy is still coming back to, do you remember? That reversible means that there are two arrows, two things are happening simultaneously. NaCl is breaking down into Na plus and Cl minus. Cl minus and Na plus are also joining back to give NaCl and at the same rate. At the same. So the rate this salt is breaking down to give Na plus and Cl minus. It's the same rate at which Na plus and Cl minus is joining back to give NaC. So first things you must understand. Going forward, what is happening? Dissolution. The salt is dissolving. Going forward, the salt is dissolved. But coming backward, this precipitation is what? Class, anytime a salt no longer wants to dissolve, the name we call it is precipitation. The process of a salt coming out of a solution, I don't want to be dissolved again. Precipitation. Remember, imagine you're cooking your soup. You put salt, and the salt say, I know they agree for anybody, it comes out. The process of your salt coming out of the solution, but salt cannot just come out by itself. There are some conditions that must be met. Whether the temperature, because solubility is temperature dependent, class. There are some salts that will not dissolve at a particular temperature. This normal table salt we use, why it's popular in cooking is that it's the one that can dissolve in several temperatures. If your water is very cold or you put salt, it will enter. If your water is very hot, you put salt, it will. You're cooking at a very high temperature, you put salt to enter. But there are some salts that cannot dissolve at just any temperature. Do you understand? So class, follow me. This salt dissolving is the process before. What is happening before the reaction of this equilibrium is dissolution. What is happening in the backward reaction is precipitation. So as I said, precipitation is the process, is not the process of this or what when the salt no longer wants to dissolve and it now wants to come out of the solution as a crystal. It's called precipitation. Now for there to be equilibrium in this reaction, the rate of dissolution, the rate of what? Must be equal to what? Thank you. The rate of dissolution must be equal to the rate of precipitation. The rate of dissolution must be equal to the rate of what? Precipitation. Class, if you have to write down the equilibrium constant for this reaction, because it's in equilibrium, right? Every reaction that is in equilibrium will have an equilibrium constant. Class, but do you know the funny thing? When we're dealing with salts specifically, when dealing with solubility equilibrium of salts, the Kc has its own special name. We don't call it Kc, we call it Ksp. Ks what? So class, it is still Kco, but we just changing it to Ksp. Solubility product constant. Solubility product. Solubility product constant. Solubility product what? Constant. Ksp. So class, when dealing with salts, the Kc for salt, don't call it Kc. Yes, we know it is Kc, equilibrium constant, right? But the special name given to it is solubility product. Class, the Ksp of this salt, do not forget that I told you that when someone is a solid, his activity is what? 1. If you are a liquid, the activity is only those in aqueous or gases that do not have activity of 1. So if I write down the Ksp of this salt, it's product divided by reactants, right? So that will be concentration of Na plus, because it's aqueous, it exists, right? Times concentration of Cl minus, it exists, right? Divided by, what is solid? Activity of solid is what? 1, divided by 1. And class, anybody divided by 1 is that person, right? So, to call the long solution, the Ksp of this reaction is just Na plus times Cl minus. The Ksp of this reaction is what? Concentration of Na plus times concentration of Cl minus. So class, if you ever have to find the Ksp of a salt, what you just need is the concentration of the ions that makes up the salts. If you have to find the Ksp of any salt in a reaction, you do not even need the concentration of the salt itself. You just need the concentration of the ions that make up the what? Salt. Let's look at other salts. For example, if the salt were to be Na2SO4, solid. All salts before they dissolve, they are in solid, right? Now dissolving now, as soon as the salt starts dissolving to break down into component ions, because we have Na2, let's call it 2Na plus. Plus, it's important at this point that you should be versatile and you must be good in ions, how to break down ions in this aspect of equilibrium. You must know the charge, expected charge an ion should have easily. Go and work on your foundation of chemistry if you have issues in that. SO4 is normally 2 minus. You should remember your radicals. SO4 is 2 minus. NO3. What's the charge on NO3? NO3. NO3 is what? Because someone gives you a sort of NO3, you want to break it down. If you don't know the charge NO3 carries, you are already starting feeling. PO4, what is the charge on PO4? 2 minus. It's 3 minus. PO4 is 3. You see, so only this thing now has finished. No matter what I teach you here, you don't know this thing. We are very foundation. PO4 is 3. Because someone can give you Na3, PO4. What is OH? Everybody should know this one. OH is minus. So please go and study your radicals and their charges they will carry. What is CO3? What is CO3? Huh? 2 minus. What is SO4? What is SO3? SO4 is 2 minus. What is SO3? Careful. Minus 1, right? Because the thing are reduced, right? It's still 2. SO3 is still 2 minus. Please take. No, SO3 is still 2 minus. So please take note of charges. Take note of what? Charges that radicals carry. Now, this aqueous, as soon as the salt dissolves this component, is now aqueous. The KSP, condition of Na plus, to raise the power of the coefficient, condition of SO4, 2 minus, raise the power of what? 1. It doesn't have any coefficient here, right? So you call it 1, right? All over, what is solid? Divided by, are we following class? Good. Class. We also have relationship between Q and KSP. Do you remember when we had relationship between Q and KC? Right? We also have relationship between Q and what? KSP. Class. It's not difficult. When Q is less than KSP, you can predict what is happening in the reaction. When Q is greater than KSP, you can predict what is happening in the PS. When Q is equal to KSP, you can predict what's happening in the what? Reaction. So let's start when Q is less than KSP. Class. When Q is less than KSP, the forward reaction is stable. That is, what is happening? Dissolution. When Q is less than KSP, the forward reaction is stable. Dissolution. When Q is greater than KSP, the backward reaction is stable. Precipitate. When Q equals to KSP, reactions are equilibrium. Neither dissolution nor precipitation is stable. There's balance. There's what? There's balance between dissolution and precipitation. There's balance between dissolution and what? Precipitation. Right now, common ion effect. Common ion effect. Common what? Common ion effects. Common ion effects. Common ion effects. Common ion effect. Follow me. Common ion effect. Are you there? Common ion effect. This is the decrease in solubility of a sparingly soluble salt. Common ion effect is a decrease. Is a decrease in solubility of a sparingly soluble salt. Common ion effect is a decrease in solubility of a sparingly soluble salts. Common ion effect is the what? Decrease in solubility of a sparingly soluble salt. Sparingly means partially soluble. Sparingly means partially what? On the board. Sparingly soluble salt. Sparingly means partially, not fully soluble. Common ion effect is the decrease in solubility of what? Sparingly soluble salt due to the presence in solution of a common ion. Due to the presence in the solution of a common ion. Due to the presence in the solution of a common ion. due to the presence in the solution of a what? Common ion. Class. Due to the presence in the solution of a what? Common ion. Class. If you have a salt Na2CO3, and instead of dissolving this salt in water, you dissolve it in a solution that contains CaCO3. Class, normally Na2CO3 will dissolve into 2Na plus CO3, 2 minus. Class, who remembers that there are 3 factors that affect equilibrium position? Remember? Pressure, temperature, and concern. Class, that constitution is very important in this aspect of salts. Class, that's what? Concentration is very important in this aspect. Class, follow me. As it stands now, this reaction is in equilibrium. But let me tell you, if for any other reason you increase the concentration of CO3, if you increase the concentration of CO, remember what I taught you yesterday, where do you think the concentration will shift to, left or right? If you increase the concentration of CO3, left or right? Why left? Since you have increased CO3, for the equilibrium to be established back, the equilibrium position will shift to the left because you have favored the right, right? By increasing CO3, you have favored the right, meaning that the left is disfavored. So the system is like the judge, it's like the balance, like the referee. If one person is being favored or treated unfairly, this system will shift and say, come, let's form more of this. Something is wrong in this system. One person has been increased on the right hand side. We have to come and increase the left hand side as. So the equilibrium position will shift to the what? Left. Class, if the equilibrium position shifts to the left, what is the implication of that? It means that, does it mean that there will be more dissolution or more precipitation? Would there be more dissolution or more precipitation? Thank you. Because going to the left means coming back. What that happens when going back? Precipitate. Because when these salts are going back to form this, precipitation is occurring, right? And class, if precipitation is occurring, is there increase in solubility of the salt or decrease in solubility of the salt? God bless you. Thank you. Decrease in solubility of the, because for precipitation to be occurring more than dissolution, there will be decrease in solubility. And that is what happens in common ion effect, class. So anything that will cause the increase in concentration of any of these ions is common ion. What can lead to increase in concentration of this common ion? Class, if you dissolve this salt in a solution that contains CaCO3. Class, you dissolve this salt in a solution that contains CaCO3. CaCO3 has a common ion with Na2CO3, which is CO3CO. So if you dissolve this salt in any solution that contains an ion like itself, you're already inducing common ion effect. That's what we call common. They have the same common ion. They have one ion in common. That's what we call common. This ion will also dissolve to give Ca2 plus CO3 2. So total concentration of CO3 is increased. Because Ca will not affect, Na and Ca are not the same, it doesn't affect you. This is but this person is the same with this person. So the total concentration of CO3 in the solution is what? So common ion effect is induced or happens or takes place when a salt is dissolved in a solution that already contains an ion that salt has. Common ion effect takes place when a salt is dissolved in a solution that already contains what? A ion that salt. So you dissolve Na2CO3 inside the solution that contains CaCO3. CO3 meeting CO3 means that it's going to be high concentration of CO3, unusually favoring CO3 over the others, and it will shift the equilibrium position so that the equilibrium can be established back, shift it to the left, which will lead to more precipitation, and by there being more precipitation, there will decrease in solubility. So if you look at the definition of common ion effect, it makes sense. We say it's a decrease in solubility of the sparingly soluble salt, right? Due to the presence in the solution of a common ion. So what common ion does to a salt is that it reduces the solubility of the salt. Common ion reduces the solubility of the salt. Let's take question. Calculate the molar solubility of AgCl. 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 Calculate the molar solubility of what? AgCl. Open bracket Ksp equals, open bracket Ksp equals 1.8 times 10 raised to the minus 10. Calculate the molar solubility of AgCl. Open bracket Ksp equals 1.8 times 10 raised to the minus 10. Class, remember that Kc does not have a unit, right? Ksp also does not have a unit because Ksp and Kc mean the same, just that we're dealing with salt. So we're no longer calling it Kc, we're calling it Ks. So if Kc does not have a unit, Ksp does not also have a, you can say 1.8 times 10 raised to the minus 8. In pure water, Calculate the molar solubility of AgCl. Ksp is 1.8 times 10 raised to the minus 10. Okay, they didn't just say in gram per liter. In gram per liter when dissolved in pure water. When dissolved in what? Right, this last part of the question, when dissolved in pure water is very important. When dissolved in. You know why it's important? By dissolving AgCl in pure water, we are sure that common ion effect cannot affect our calculations. Because pure water H2O does not have any common ion with AgC. Because there's another question they can give you. Calculate the molar solubility of AgCl when dissolved in a solution containing CaCl2. Cl, the way you solve it is different. Please take notes. When a salt is dissolved in pure water, class, it's easy. When a salt is dissolved in a solution containing the common ion with the salt, the calculation is different. Let's start with the pure water first. So they ask us to find the molar solubility. Class, molar solubility simply means concentration. But they ask us to find the solubility in gram per liter. We have to be very careful. Class, follow me, let's go. Because we'll first get our answer in mole per liter. And we need to change it to gram per. Class, the first thing, so when they give you a question like this, calculate the molar solubility of AgCl. Meaning they ask you to find the concentration of AgC. You first write down the dissolution equation, the equilibrium equation, the solubility equilibrium equation of the salt. You won't be given that. Of course, you expect all salts to be solid before they won't dissolve. Now, once they start dissolving, AgCl will break down into Ag plus Cl minus. Class, anytime they give a salt that just has Ag, like there's no number between them, just the element and this element. Just know that they are both just monoatomic and they are monoionic. Like, just know that the first part of the salt is always the positive part. The second part of the salt is the negative. So just carry Ag plus, give Cl minus. But even they say something like Pb, look at the difference between this and that, PbCl2. Class, you cannot just come here and just say Pb plus Cl minus. You can't do that. You can't do. Why? Because now AgCl there's no number between them. But they say 2 here, class. What you have to let me be the first part of every salt is always the positive. So you are correct, this positive. But class, the charge that this positive will carry is the number with this Cl. 2 plus. Any number that is here, put it here. Any number that is here, put it here. This minus is also correct, but the number that is here, Pb is not carrying, so let's just call it 1. So minus. That's a shortcut for this. Do you understand? So if I give you something like this, now watch. Na3PO4. The first part of every salt is the positive. So Na is plus, we know. PO4 is minus, But class, because there's a number between them. Anytime there's a number here, there's a number here, class. You can't just say Na plus and PO4 minus. But one thing is correct. Every first part of every salt is the positive side. And the second part is negative. What we need to do is now to that this 3 belongs to this PO4. And this PO4 is not carrying any number, so it's 1. This 1 belongs to Na. So Na is plus. And this 3 is PO4 3. So exchange the number, exchange the what? I'm just doing this for maybe someone that might not really know this. Most of you should know this. Now, moving forward. If there's anybody that doesn't understand this part, anytime you understand it's just a waste of time. You don't understand how they're always breaking this thing down. When the exam, they'll give a question, they will not give you the equation, it's you that will break it. Class, follow me now. What's the KSP for this formula for the KSP for this reaction? Concentration of Ag plus, right? Times Cl all over, which you don't need to mention 1, right? So this is just the KSP, right? Now, if they give us the KSP, Yes, 1.8 times 10 raised by minus. But they ask us to find this molar solubility of this salt, AgCl. So they are not even asking us to find the ions. They ask us to find the salts. But in this our formula, the salt is not even represented because its acidity is 1. How will we now find the molar solubility of this salt if it's not even in our formula? Follow me. Go look at the question again. Say find the molar solubility of AgC, and before it's even decomposed, so in the solid form. But looking at your formula, there's no way AgCl appears as a salt. This is Ag plus aqueous, right? And this Cl minus. But they ask us to find the molar solubility of AgCl, which means the concentration of AgC. See how you're going to do it. Follow me. Let me tell you, go back to the equation. Class, 1 mole of the salt gave 1 mole of Ag plus and 1 mole of Cl. Right? Let me just tell you something now, class. Meaning that, using their stoichiometric coefficient, if the concentration of AgCl is X, the concentration of Ag plus must also be X, and Cl minus is also X. Because they have the same stoichiometric coefficient. Let me give you another example. If this were to be PbCl2, when it breaks down, please follow carefully. Remember what I taught you with Pb? Pb will break this 2, right? Yeah. 2 plus and Cl minus 1. Because Pb is having 1. First part of every salt is positive, second part is negative. Now, follow me. If the concentration of this salt is, okay, this Cl is going to be 2Cl. Because Cl2 means 2. Because Cl is occurring twice, right? If you don't put this 2 here, the equation is not balanced. If the concentration of this salt is X, what is the stoichiometric coefficient? 1, 1, 2. 1, 1 what? Follow carefully. 1, 1, 2, 1, 1. So if this guy is X, this is also X, but they are 1, 1, right? But this guy is 2X. 2 what? If you have another one, Na3PO4. When it breaks down, it's going to give you 3Na plus 3 because Na3 means 3N. Just like we said, Cl2 is 2C, 3Na plus PO4, 3. So this 1 mole of the salt gave 3 moles of Na plus aqueous and just 1 mole of PO4. So if the concentration of this salt is X, this must be 3 and this must be. Are we following? Let's come back to our main question now. So if the concentration of this salt is X, because they ask us to find the molar solubility of this salt, which is what? X, which is what? Let us call it X, we don't know, let's call it. But if this guy is X, based on their stoichiometric coefficient in the balanced equation, this must also be. What does that mean, class? It means that if I can get X, I've gotten the concentration of AgCl. Don't forget that KSP is concentration of Ag plus times concentration of Cl. So without having AgCl in my formula, I can still get the concentration of AgCl. Because KSP is 1.8 times 10 raised to minus 8 equals to what's the concentration of Ag plus? X. Cl minus X. X times X. So 1.8 times 10 raised to minus 8 equals to X. How do we make X square root of formula? We can find the square root of both. We can find the square root of both sides to make X square root of the. Do you agree? So the X in I equals to square roots. 1.8 times 10 raised to minus, was it minus 8 or minus 10? Minus 10, minus. And once you have gotten X, have you not gotten the concentration of AgCl? What is the square root of 1.8 times 10 raised to minus 10? 1.34 times 10 raised to minus 5. Class, for this concentration is in mole per liter. Mole per what? But what the question should find it in? Find the concentration in gram per class. From mole per liter to gram per liter, normally you should be able to do it. How do you go from mole per liter to gram per liter? By multiplying by the molar rate, the molar mass of the salt. Multiply this value you got by the molar mass of the salt, AgCl. Class, from mole per liter to gram per liter means they're asking you to find the mass concentration. Mole per liter means molar concern. Gram per liter means mass concern. PPT, gram per liter. PP, parts per thousand. From first semester, parts per. Class, so anytime you have a concentration, those watching us online, in mole per liter, and you have to find a gram per liter, Simply find the molar mass of the salt, which you are not given, but you are expected to know at this level of university. Any good student should know that AG is 108. And CL is 35 points. If this was PB, PB is 207. 20 what? You should just know it. As you are getting higher, too much is given, much is expected. In 200 level, you start seeing some questions in your chemistry. Before you do chemistry 200 level, that they expect that you should have trained knowing this thing already in 200 level. You start giving a question and they'll start putting you at the pedestal that in 200 level student should be. So your kind of exam in 200 level will be different. You won't be giving some simple things. AG you should have known it from secondary school. They give you barium. You don't think twice. What is barium? 137. You don't think. You must get to that level as you're going higher. Class now. So AG is 108, CL is 35.5. What is 108 plus 35.5? 14 grams. So the molar mass of AgCl is 143.5. The molar mass of AgCl is 143.5. So what we need to do to change this from mole per liter to gram per liter, what do we need to do? Multiply by 143.5. So 1.34 times 10 raised to minus 5 multiplied by 143.5. What will you have? 1.34 times 10 raised to minus 5 multiplied by 143.5 will be your final answer in gram per liters. Will be your final answer in gram per liters. Someone help us. 1.92 times 10 raised to power minus 3 gram per. This is the solubility of the salt in gram per liter. This is the solubility of the salt in gram per liter. Get ready for the second question quickly. Get ready for the second question quickly. Get ready for the second question quickly. This one will be more difficult because to be in a common ion, to be in a what? Remember that this guy dissolved in pure water, but see how we know the state. Now imagine when it's in a common ion. This guy dissolved in pure. Quickly, are you ready? Look like you're ready. Okay, let's go. Calculate the molar solubility of AgCl, the same AgCl, in gram per liter. Calculate the molar solubility of AgCl in gram per liter, but in 1 times 10 raised to minus 3 m concentration of CaCl2. I'll come again. Calculate the molar solubility of AgCl in gram per liter. Calculate the molar solubility. Calculate the molar solubility of AgCl in what? Gram per liter. In gram per, but in 1 times 10 raised to minus 3. In 1 times 10 raised to what? Minus 3 m concentration. In 1 times 10 raised to minus 3 m. M means capital letter M, molarity, right? 1 times 10 raised to minus 3 m concentration of CaCl2. In 1 times 10 raised to minus 3 m concentration of CaCl2. Why did they not give us the KS for the second question? Because they still AgCl, so still use the same KS. Still use the same KS. It's AgCl, the salt has not changed, right? It's just dissolving in a different solution now, right? So the first question is dissolved in pure water. Second question is dissolved in a solution of CaCl. So still maintain the KSP they gave you for AgCl. The salt did not change. Class, what do we do when this AgCl dissolved in a solution of CaCl2? Follow me. AgCl is dissolving in a solution of CaCl2. Follow me. Now we are going to write two equations. When a salt dissolves in a solution of another ionic compound, because even CaCl2 is still an ionic compound. It's a polar compound. It's a polar class. AgCl, we already know how it will go. Ag plus Cl. If this is X, this X is also, follow me now. But it's 1, 1, 1, right? But it dissolves in a solution that contains CaCl2. So CaCl2 will also have to be involved and dissolve. CaCl2 will dissolve into Ca2 plus 2Cl. class, this is 1, 1, 2. But good enough, they gave us the concentration of this guy. You didn't give a question of CaCl2. What is it? 1 times 10 raised to minus 3. Did they say minus 3? Yeah. This is the question of CaCl2. But class, using the stoichiometric question, if this is 1, if this guy is 1 times 10 raised to minus 3, this guy is also 1 times 10 raised to minus 3. Because they have the same stoichiometric question. 1. Please follow. Don't fall into the position of just writing. Understand. If you are scared that you will lose the notes, remember that you can still watch the video again and write the notes down. But your understanding, you cannot, if you just try and understand first. Why do they have the same concentration? Because of the same stoichiometry. What will this guy concentration now be? It will be 2 times of this, right? 2 times 1 times 10 raised to minus 2 times 1 is what? 2. So this is 2 times 10 raised to minus 3 and plus. Among these 3 people, the only person that is important to me is this Cl. Is what? Because it's the only person that is common with my main salt that is not in him. I don't have any business with this guy or this guy. I only need this guy to use it to get this. Are we following class? So this salt dissolved in this solution of CaCl2. This guy cannot affect my salt. This guy cannot affect my. Only this guy looks exactly like what I have already can affect my. Because it's a common ion. So if this salt dissolves in this salt class, before this guy dissolves, the concentration of Cl is just X. But after it dissolves in this guy, it will be X plus whatever the concentration of this guy is. What is 2 times 10 raised to minus 3 in full decimal? 0.00200. So the concentration of Cl minus is X plus 0.002M. But this guy is still XM. And this guy is still X. Remember that this thing stands for constant. So do you see how common ion has already increased 1 person? And this guy is still X, this guy is still X. How will the reaction not what? The reaction will also do what? React back and say, okay, let us shift to this guy. This guy is very favorable, but let us shift back. Now, class. Well, what we need from this CaCl, which is this Cl. But remember that we did not write down this equation like this, we wouldn't have known the concentration of this Cl, right? So you need to write it down. Remember that all these things are written down in your exam does not even matter, it's just the final. All these things just be in one rough sheet or one table like that, or one of your hands. They don't like to carry paper and enter the exam, I don't know if they were allowed. Or somewhere. You cannot solve on your question paper because that's what you submit as when they will mark your answer. If you solve your question paper, you have already scattered your own score. But that's when they will mark. They won't give you an answer sheet. Your answer is on your question. So you cannot even carry your question paper home. So they will answer. You people don't release their questions. So if you see past questions, study it very well. But why are they hiding it? That's what you should be asking yourself. It can help you. Even if you don't repeat the exact question, it can help you. They study what they said last year, 2 years ago, it can help. You know, class. What would now be the KSP of AgCl? The KSP of AgCl is concentration of Ag plus times concentration of Cl. What is the KSP of AgCl? 1.8 times 10 raised to minus 10. What concentration of Ag plus? X. Ag plus is still. But what is the concentration of Cl minus? X plus 0.00. So this is 1.8 times 10 raised to minus 10. Start bringing your calculator. This is quadratic equation we are going already. X times X. So use X to open the X times X, X squared. Now plus X times 0.002, 0.002. Bring 1.8 times 10 raised to minus 10 to this side to complete the quadratic. So what we have here is X squared plus 0.002x. When this guy comes to becomes what? Minus 1.8 times 10 raised to minus everything equals what? Because nobody's in this side again, 0. Class, if you want to solve this quadratic with your normal hand, you could use time in the exam. So you want to factorize. Remember that factorization? Multiply A times C. Then find 2 numbers that can, yeah, try it now, let's see. Find 2 numbers that can, then you multiply it, give you this. Remember that thing in quadratic you do? When they add up, you give this. Yeah. Exam will finish, only will be in the all. Everybody has done it. Say, are you still there? Meet us next year. Just continue the exam in 200 level on mathematics. Now follow me, class. This calculator that will deal with this. Just on your calculator. See your calculator. Don't show your calculator. That shortcut will learn the first semester. It's still going to help you. And shortcut did not work. It's still going to help you second semester. But not teaching that just for one exam. Just Nigerian students, they are so short-sighted. Once you show them, it doesn't work that time. And it doesn't work. It can still help you long term. This year, second semester now, you're still using that. You can still use that same shortcut. So when you maybe study something, it not work for one time. Don't just think that knowledge is wasted. Don't just throw it away. It can still help you. So on your calculator, let me see if you remember shortcut quadratic that we taught first semester. It's helping us second because you cannot solve it with your hand. Class, saw this quadratic with your shortcut. I taught you first semester. Remember, I think you remember what to do. Okay, we have this some students that were not here in first semester. Let me just show you. Press mode. You press mode 3 times in your calculator. Oh, it's a senior colleague. Press mode once. For senior colleague, junior colleague that you press mode 3. Junior colleague, you press mode once, right? When you press mode, you press 5 for equation, right? After pressing mode, press 5 for. Without this shortcut, you cannot get this in the exam. I'm sure. You cannot get this with normal solving unless you use almighty, but you still take time. But this high decimal, almighty formula will still deal with it, but you will waste time. As minus b plus or minus, right? You do your. It's about class. The best thing is still to use shortcut. Press mode, then press 5 for equation. When you press 5, what will you press for quadratic? You press 3 for quadratic. It will not ask for A. A is the equation of x, which is what? So A is 1. You press 1 and press equal to. Now press B is what? If you have pressed 1 and you press equal to, you also have moved to B now. 0.002, you press equal to. What is C? Thank you. Thank you. I thought you just said it without the minus. Minus. Then press equal to. Then press equal to. It will give you one wrong answer and one right answer. But it will give you one negative answer and one positive. Our condition cannot be negative, so if the positive answer is declared. So what's the answer? Who has done it? 8.9. 8.99 times 10 raised to minus 8 m. 8.99 times 10 raised to minus 8 m. That is the concentration of the salt, IGCSE. But did they not say we should find it in gram per liter? So what we now do to change from mole per liter to gram per liter, what do you do? Multiply by the molar. Since it's the same salt, original molar mass 143.5, remember? IGCSE 143 point. Now give me the final answer in gram per liter. Give me the final answer in gram per liter. 1.29 times 10 raised to minus 5 gram per 1.29 times 10 raised to minus 5 gram per. Okay. Can someone confirm that? Is that correct? Quickly, let's take another question. Correctly? Okay. While I'm going to take this question down, a 0.15 m solution. A 0.15 m solution. A what? Okay, don't worry, it's a similar question, similar. Let's go to write down now. Class, write down. Write down acid-base equilibria. Acid-base. Write down acid-base equilibria. Acid-base equilibria. Acid-base equilibria. Acid-base equilibria. Acid-base equilibria. So class, we looked at different types of equilibria. We looked at homogeneous equilibria, heterogeneous equilibria, solubility equilibria. Now it's time for acid-base equilibria. Since acid and base mentioned in this topic, normally I should skip the part where I define acid and base, because you can't be in university and you cannot define acid and base. Just to remind you that acid is a substance that what? Release hydrogen ion as only positive when dissolved in a solution. Base, hydroxyl ion, right? But what we quickly go to now you know properties of an acid already, right? Acids are what? They turn blue super red, right? They are corrosive. What else do you know about acid? Sour taste. You said it before, right? Okay, go ahead. Go ahead, I'm joking, but you're correct. Go ahead. Or that they are corrosive to the skin, right? And this and that and that. Now, class, quickly, so skip all this. Let's look at the three theories of acid and base. We have Arrhenius theory. Three theories of acid and base. Arrhenius theory, bronsted-lowry theory, and Lewis theory. Class, Arrhenius theory, bronsted-lowry theory, and Lewis theory. Arrhenius theory, bronsted-lowry theory, Lewis theory. Arrhenius theory, class, it's not actually like a theory like law. It's almost like a definition, how they see what Arrhenius theory of acid and base is just how does Arrhenius define acid and base. Bronsted-lowry theory of acid and base is how does Bronsted-lowry define acid and Lewis theory of acid and base is how does Lewis define acid and. So it's not like maybe a law that states that, no, it's just their definition of acid and base. Because these three scientists were the major scientists that defined acid and base uniquely, differently. And the three definitions were correct. So Arrhenius theory, let's start, states that an acid is a substance Arrhenius theory states that an acid is a substance that contains hydrogen atom. An acid is a substance that contains hydrogen atom and produces hydrogen ion in an aqueous medium. States that an acid is a substance that contains hydrogen atom. That contains what? Hydrogen atom. Arrhenius theory states that an acid is a substance that contains hydrogen atom. Arrhenius theory states that an acid is a substance that contains hydrogen atom and produces hydrogen ion in an aqueous medium. And produces hydrogen ion in an aqueous medium. And produces hydrogen ion in an aqueous. And a base is a substance. And a base is something that contains hydroxyl group. And a base is something that contains hydroxyl group. And produces hydroxyl ion OH minus. And produces hydroxyl ion in an aqueous medium. Arrhenius said that acid substance that produces what? Hydrogen ion, right? In an aqueous medium. Base produces hydrogen ion in an aqueous. But class, if we only stop at Arrhenius' definition of acid and base, It means that anybody that does not have OH or H will not be referred to as an acid. So Arrhenius theory has limitation, it's limited. So where hydrogen and OH minus does not work, other definitions must come in. Other definitions what? Before we go to the bronsted-lowry, Arrhenius also define neutralization. What is Arrhenius' definition of neutralization? Because we all know that neutralization is acid and base if it's salt and water, right? So neutralization according to Arrhenius theory is the reaction between an hydrogen proton, H+. Neutralization according to Arrhenius theory, neutralization according to Arrhenius is the reaction between an hydrogen ion and an hydroxy group to form water, to form class. You must know that acid-base equilibria is still a subtopic of heterogeneous equilibria, because if you look at this reaction now, you see that this aqueous to give what? Liquid. Aqueous to give what? Heterogeneous, but they're not in the same phase. So all you understand, all what you knew about heterogeneous equilibria still applies. Just that class, the equilibrium constant, if it involves water, is Kw instead of Kc. When we did salt plus Ksp, right? When we did salt plus Ks, so Kc changed to Ksp. Now we're dealing with acid, base, and water. If it's water, Kw. If it's acid, Ka. If it's base, funny thing that Kw is actually equals to Ka times K. Kw equals to what? Ka multiplied by K. We'll come to that later. Class, bronsted-lowry theory. It states that, bronsted-lowry theory states that an acid is a substance that is capable of donating a proton. Bronsted-lowry theory states that an acid is a substance that is capable of donating a proton. Bronsted-lowry theory states that an acid is a substance that is capable of donating a proton. Bronsted-lowry theory states that an acid is a substance that is capable of donating a what? Proton. And a base is a substance that is capable of accepting a proton. And a base is a substance that is capable of accepting a proton. An acid is a substance that is capable of donating a proton. So an acid is a proton donor. Proton. So in the exam, you could be asked, according to bronsted-lowry theory, an acid is a dash, is a proton donor. And a base is a proton acceptor. Proton what? Class, we now go to Lewis theory. Lewis theory states that an acid is any substance that can accept a lone pair of electrons. An acid is any substance that can accept a lone pair of electrons. So according to Lewis theory, an acid is an electron acceptor. An acid is any substance that can accept a lone pair of electrons. Any substance that can accept a lone pair of what? Is an acid. Why a base? Is any substance that can donate a lone pair of electrons. Base. Any substance that can donate a lone pair of what? Electron donor, electron what? Donor. So acid is an electron acceptor, base an electron donor. Acid is an electron acceptor, base is an electron donor. Class. Quickly write down. Amphoteric substance. Amphoteric. Amphoteric substance is a substance that can act both as acid and as a base. Amphoteric substance is a substance that can act both as an acid and as a can also act as a base. Another name for amphoteric substance is amphiprotic. Another name for amphoteric substance is what? Amphiprotic substance. Another name for amphoteric substance, amphiprotic substance. A good example of amphoteric substance is water. Another good example is AlOH3. Can act both as an acid and as a base. Write down monoprotic and polyprotic acid. Monoprotic and polyprotic acid. Monoprotic and polyprotic acid. Monoprotic and what? Class, very simple, don't mind it. It's just monoprotic acid can only donate one hydrogen ion. A monoprotic acid is an acid that what? When dissolved in an aqueous medium, releases only one hydrogen. It has capacity to only release one hydrogen ion. It can only release one proton. A monoprotic acid is an acid that can only donate one proton or release one proton when dissolved in an aqueous medium. When dissolved in an aqueous medium, it can only release, it only has one what ionizable hydrogen ion. It can only release one hydrogen ion. You can pick any of the things I'm saying. They all mean the same. The one you understand best. But by now, as I've said different things, you should have understood the concept. Any acid that can donate only one hydrogen, when dissolved in an aqueous medium, it can only release one monoproton. Example is obvious, HCl, right? HCl can release one hydrogen, HNO3. But polyprotic can have more than one ionizable hydrogen ion. Class, write down. Polyprotic acids that have more than one ionizable hydrogen ion. Polyprotic acid is one that has more than one what? Ionizable hydrogen ion. H2SO4. H3PO. H2SO4, H3PO4, H2CO3. When an acid can produce or release more than one hydrogen ion when dissolved in an aqueous medium, that acid is said to be polyprotic. Poly what? Protic acid. Autoionization. Autoionizations also known as self-ionization. Self what? Autoionization. So we learn also what's small movie. Yes, left. After the class, can go and see the movie. Autoionization already defines itself, self-ionize. Class, usually when substances dissolve in water, they ionize. Ionize means they split into their component ions. Please pause the video, pause the video. Press the right thing. Class, when the substance dissolves in water, ionization will occur because the substance will split into its component ions. For class, so water is usually the chief ionizer of all substances. So who would then ionize water? Only water is capable of ionizing it. And the process of water ionizing itself is called autos. What are you saying now? The process of water ionizing itself is called auto-ionization. Self-ionize. That's just the now class. You could be asked to write down what the reaction of when what auto-ionization occurs in water. This is what happens during self-ionization of waters. Two liquid water ionize in each other. So it means anytime you are turning water into water, you are already doing auto-ionization without knowing. Liquid plus liquid, H3O plus OH minus. This forms. For class, what's the KW for this reaction? This liquid, so the activity is what? So only the aqueous form is considered, right? So KW, that's the water dissociation constant or water ionization constant, is H3O plus times OH. And class, the value of this KW has already been calculated to be equal to 1.0 times 10 raised to the minus 14. Don't forget that this does not have a unit. K does not have a. There's a constant. It's a what? Because the product of H3O plus and OH minus is a constant of 1.0 times 10 raised to the minus 14. Let's now go to concept of conjugate acid, conjugate base. Subheading: conjugate acid, conjugate base. So the concept of conjugate acid and conjugate base was actually proposed by which of the scientists? I want to ask you. Who proposed conjugate acid, conjugate base? Is it Arrhenius? Is it bronsted-lowry? Is it Lewis? Who proposed the concept of conjugate acid and conjugate base? Arrhenius, bronsted-lowry, Lewis. I will thank God for everything, I'm sure. Class is bronsted-lowry. Bronsted-lowry, please take. No, it's only your textbook here. So that's why when I'm doing my final exam, I usually like using this. I can follow. I will not miss any key points. Your textbook here, bronsted-lowry. I also added the year. Remember that they both all. Someone was writing the year when they postulated their theories. Now, a conjugate acid is a species formed. A conjugate acid is a species formed when a bronsted-lowry base accepts a proton. A conjugate acid is a species formed when it what? A conjugate acid is a species formed when a bronsted-lowry base accepts a proton. Conjugate acid is a species formed when a bronsted-lowry what? Base accepts a proton. A conjugate acid is a species formed when a bronsted-lowry base accepts a proton. Class, are you aware that during the auto-ionization of water, one of these species acts as the acid, one acts as the. Because I remember telling you that water is what harmful, can behave as an acid and can behave as a base. Class, if ever you are asked to write down the conjugate acid of water, H2O. The conjugate acid of water is H3O plus. So water as a base, class, the only person that can have a conjugate acid is a conjugate base. Sorry, what am I saying? Sorry. The only person that can have a conjugate acid is a base. So all base have their conjugate acid, and all acid have their conjugate base. So there's what we call acid conjugate base pair. Acid what? Acid conjugate base or base conjugate acid pair. Class, you could be given any acid and asked to write down what will be the conjugate base of that acid. I'll teach you how to do that. And you give it any base and write the conjugate acid of that base. So you could give it an acid and say write down the conjugate base of that acid. Or a base, write down the conjugate acid of that base. Class, when water is a base, the conjugate acid of this base is H3O plus. We'll go back to your definition of conjugate acid. We say it's a species that is formed when a bronsted-lowry base accepts a class. When this base has accepted the proton H2 to H, its conjugate acid is. Now let's define conjugate base. A conjugate base is defined, is in species formed when an acid donates a proton. The species formed when an acid donates a proton. The conjugate base is a species formed when an acid donates a what? Proton. So what's the conjugate base of this water that is an acid? OH minus. Conjugate base is a species formed when an acid donates a. So H2O as a base, as an acid, H2O as an is pair, its conjugate base is who? OH minus. OH what? The conjugate base of water as an acid is OH minus. But the conjugate acid of water as a base, the conjugate acid of water as a base, H3O. So the species, to cut the long story short, the species formed when a base accepts a proton or gains a proton is conjugate acid. But when an acid loses a proton, their species form is conjugate base. So don't be surprised that water is occurring twice, as an acid and as a base. Let me pause it. Now, if what is not water, what is HCl? And he has to find the conjugate base of, well, HCl is an acid, right? The only person can be asked to find for an acid is conjugate base. This is an acid. What will be the conjugate base of HCl? Cl minus. This is the conjugate base. So please take note that the conjugate base of an acid is formed when the acid loses the hydrogen proton. When the acid loses the hydrogen proton. Very easy to identify. Why? The conjugate acid of a base is formed when the base also loses the OH minus. The conjugate base is formed as well. Are we together? Yes. If you have to find the conjugate base of a base like NaOH, NaO, you have Na plus plus OH minus. If you have to find the conjugate acid, this is a base, right? The conjugate acid is Na plus. Conjugate acid is what? HCl is conjugate basis Cl minus. NaOH conjugate acid is Na plus. Now let's go to strengths. Strength of acids. Strength of strength of, but let's take this question. Calculate the molar concentration. Calculate the molar concentration of H3O plus and OH minus. Calculate the molar concentration of H3O plus and OH minus ions. Calculate the molar concentration of H3O plus and OH minus ion in 0.001 m. In 0.001 m. Calculate the molar concentration of H3O plus and OH minus ions. Calculate the molar concentration of H3O plus and OH minus ions in 0.001 m. CaOH2. solution. CaOH2. Calculate the molar concentration of H3O plus and OH minus ions in 0.001 m CaOH2 solutions. So we're looking for H3O plus concentration. Hello, in our class here, I don't tell you about it. And OH minus in 0.001 m CaOH2 solution. Now follow this. First of all, what happens when CaOH2 ionizes? Ca2 plus 2OH, but OH2 means 2OH. Class, the concentration of this base is 0.00. Using the stoichiometric question, this is. So if this is 0.001, we're interested in this OH. This will be 2 times. Do you agree? From our solubility we did that time, right? So knowledge builds. It goes 2 times 0.001 becomes 0.00. This is the concentration of OH minus. We've already gotten OH. But those ones to find H3O plus. If you have OH minus and you're looking for H3O plus, you must remember this formula I told you earlier. That KW is H3O plus multiplied by OH. But what is KW? 1.0. So 1.0 times 10 raised to minus 14, right? Is equal to concentration of H3O plus multiplied by concentration of OH minus. What is OH minus? Can you now see how we can get H3O plus now? You can see how H3O plus can come out. Divide both sides by 0.00. 0.002 cancels 0.002. And by the time you divide this by this, you've gotten your H3O. H3O plus will now be what? Someone give us the final answer? 5 times 10 raised to the power of minus 12. You are allowed to call this one M now because this is concentration, right? M. Concentration. Strength of acid and base, right? Under strength of acid and base, rather than leveling effect. Leveling effects. Look for engineering. Leveling. This is a phenomenon in which acids of different strengths appear to have the same strength in water. Leveling effect is a phenomenon in which acids of different strengths appear to have the same strength in water. A phenomenon in which acids of different strengths appear to have the same strength in water. When that occurs, we say leveling effect is taking place. A phenomenon in which acids of different strength appear to have the same strength in water. Class, there are so many acids, I couldn't even list all of them on the board. But I want you to know that if you ever ask which acid is known as the strongest acid ever, it's hydrogen iodide, H. At the top of the acid strength chain is hydrogen. And I'll explain why hydrogen iodide is so strong compared to all acids. So also just to know that we have organic acids and inorganic. Between inorganic and organic acid, inorganic acids are stronger than organic. listed note. When talking about acid and conjugate base and base and conjugate acid, I want you to note something. Quickly, write down notes. The stronger an acid, the weaker its conjugate base. The stronger an acid, the weaker its conjugate base. And the weaker an acid, the stronger its conjugate base. Let me play it. The stronger an acid, the weaker its conjugate base. The weaker an acid, the stronger the conjugate base. So what this means is that strong acids produce very weak conjugate base, and weak acids produce very strong conjugate base. I just thought to point this out since we're talking about strength of acid. It's a good place to point this. You can link information of that to strength of acid. Now, so a strong acid will produce what? A weaker conjugate base, and a weak acid will produce a stronger conjugate base. So let me first phenomenon in which acids of different strength, different acids have their strength. But when you now put them in water, water is a dilute solution. They now show the same level of strength. That phenomenon is known as leveling effect. It will be asked in the exam. Never forget this. Don't forget this. Now, class, let us now go to strength of binary acids. Strength of binary acids. Who are binary acids? These are acids, write down. Binary acids. These are acids that consist of hydrogen in a chemical combination with another type of element. Binary acids are acids that consist of hydrogen in a chemical combination with another type of element. Binary acids are acids that consist of hydrogen in a chemical combination with another type of what? Element. Binary acids are acids that consist of hydrogen in a chemical combination with another type of what? Element. Binary acids are acids that consist of hydrogen in a chemical combination with another type of element. HCl, HI. You can easily figure who are binary acids among this, right? Now let us look at the binary acid containing halogens. Class, if you've been in your past question, you will have seen question when they say arrange the following acid in order of increasing strength, reducing strength. We are going to that area now. How do you know who is stronger than who? We are going to that area. Let me show you the criteria. Let us start with binary acids that contain just halogens. We know that the constant in all acids is hydrogen, but halogen containing binary acid. Halogen containing what? So hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodides. Class, comparing these four, class, what makes an acid strong is the ability to release the hydrogen ion. How fast can you release the hydrogen ion will make you stronger than the other acids. Because we know that an acid is a substance that what releases hydrogen ion when dissolved in a solution. It releases hydrogen. So if everybody releases hydrogen, how do you now know it's stronger? Who can release its own faster? What will determine if an acid will be able to release hydrogen ion faster is dependent on the negative atom attached to the hydrogen class. It depends on the negative atom attached to the. Why is the electronegative atom very important? Because usually electronegative atoms are known to hold on to their. They don't easily release. They hold on. So class, if an acid is attached to a stronger electronegative atom, it will be a weak acid. Compared to an acid that is attached to a weaker electronegative. So this explains why hydrogen iodide is stronger than hydrogen fluoride. Because fluorine has a higher electronegativity. Fluorine has a higher negativity. Higher what? Compared to iodine, which has a lower electronegativity. In fact, amongst these four, iodine has the lowest electronegativity. If you remember your periodic table, electronegativity decreases down, decreases what? but increases across the period. So if you look at your group 7 elements, at the top is fluorine, bromine, iodine. So as you are going down, the electronegativity is going down. So fluorine is the most electronegative, and anytime an acid contains a strong electronegative atom, it will produce a weak. So acids containing strong electronegative atoms usually produce a weak acid. Why acids containing weak electronegative atoms produce a strong? And you understand why, right? Because iodine will easily release hydrogen compared to fluorine. Because the higher the negativity, the more difficult it is for the hydrogen atom to be released. Electronegative atom want to keep, they don't want to let go, they want to keep. But people that have lower energy can easily let go. So class, if you ask to arrange this in order of increasing strength, this less than this, less than this, this is the highest. So from lowest to increasing, but you say decreasing, that's from highest to, so you start from the highest before you go to the, so they say arrange in increasing, in decreasing. This one is in increasing, so arrange the acid in increasing, so lowest going till you get to the highest. This is the lowest, lower, low, highest. Then decreasing strength, you say HI, greater than HBr, greater than H, greater than HF. This is decreasing order. What is increasing? So right now, the strength of an acid increases as the electronegativity of the non-hydrogen atom decreases. The strength of an acid increases. The strength of an acid increases as the electronegativity. The strength of an acid does what? Increases as the electronegativity of the non-hydrogen atom decreases along the group. The strength of an acid increases. The strength of an acid does what? Increases as the electronegativity of the non-hydrogen atom decreases. Does that align with what we explained? Yes. Listen to that very well. The strength of an acid increases as the electronegativity of the non-hydrogen atom decreases. So the lower the electronegativity, the stronger the. Makes sense, right? Class, these are another binary acid, but this is group 6, the carcogens, the oxygen family. The person that has the strongest acid here, when talking from hydrogen oxide, hydrogen sulfide, and you keep going like that. As you're going down, class, the strength of the acid is reducing. So the person that has the strongest acid is HO, followed by HS, followed by what? HSC, followed by HTE. But class, if we introduce, if this becomes H2O, H2S, H2SC, and H2TE, class, the reverse will be the case. Just take note of these changes. You could be given any of these acids in the exam. When it was just HO, HS, HSC, and HTE, HO is the strongest. Once we become H2O, H2S, H2SC, and H2TE, H2O is the weakest. Please take note. All these elements belong to the same group in the periodic table. When it's just HO, HS, HSC, and HTE, HO is the strongest. But when it becomes H2, H2S, H2S, H2TE, H2O becomes the what? Weakest. You can see that I changed this from greater than to less to show that it is. What else? Yes, exactly. Strength of oxo acids. Strength of what? Strength of oxo acids. Strength of oxo acids. Strength of oxo acids. Now I want to ask you a question. An acid with a stronger bond between the two atoms and an acid with a weaker bond, who produces a stronger acid? If the bond is stronger, will it produce a stronger acid or a weaker acid? The stronger the bond, right? The weaker the. Because if the bond is strong between the hydrogen and the electronegative atom, they will not release hydrogen, right? So you need a weaker bond to produce a stronger. Does that make sense? Strength of oxo acids. Oxo acids are a family of acids that contains, to cut the long story short, they're just oxygen containing acids. Let me not use the big English they use here and you will not understand. They are oxygen containing what? Acids. Oxygen containing acids are also acids. Oxygen containing acids are also acids. Class, let me surprise you with something here. Look up, because in one case, when we compare HF, HCl, HBr, and HI, HI is the strongest, right? But when oxygen comes between them, class, the reverse is the case. Class, I can still have the same acid, but HOF, HO, HOC, HOB, and HOI. Class, just the opposite is the case. When there was no oxygen, who was the strongest? HI. When there is oxygen, H is now the weakest. So the person that is strongest is HOF. Say they give you HOF, HOCl, HOBr, and HOI, and say arranging, increasing strength. Increasing what? Coming from the lowest to the highest. Who is the lowest? Who is the lowest? HOI. Followed by HOB, followed by HOCl, followed by HO. So class, the presence of oxygen in oxo acid helps to do what? Increase the strength and changes the dynamic between the electronegative atom. Changes the dynamic between the electronegative atom. Class, let us now also still look at oxo acids. So let us pick just HOCl now. So we have HOCl, we have HClO2, we have HClO, we have HClO4. Class, in oxo acids, I want you to note, write a note. For oxo acids containing multiple oxygens, note, for oxo acids containing multiple oxygens, the more the number of oxygen atoms present, the stronger the acids. For oxo acids containing multiple oxygens, the more the number of oxygen atoms present, the stronger the acids. You see that different graduations have different rules. Because you can just bring one in there and say arrange. The rule I used to arrange, and the rule you arrange this one. For oxo acids containing multiple oxygens, right? The more the number of oxygen atoms present in the acid, the stronger the. For oxo acids containing multiple oxygens, the more the number of oxygen atoms present in the acid, the stronger the. So among HOCl, HClO2, HClO3, and HClO4, who is the strongest? HClO4 is the strongest. So arrange them in order of decreasing order. In decreasing. Decreasing means what? Highest to. So who will I mention first? Decreasing. HClO greater than HO. The more the number of oxygen, the stronger the acid. But this is also true if it was HNO3 and HNO2. HNO3 are what? It's also true. The more the number of oxygen, HNO3 has more oxygen than HNO2. So HNO3 is stronger than HNO2. It's still also true for sulfur oxo acids, sulfur containing oxo acids. H2SO4 is stronger than H2SO3. H2SO4 is stronger than what? Sulfur containing oxo acid also follow the same trend. So whether you're nitrogen containing oxo acid, sulfur containing oxo acid, or any of the halogens class, in the exam they could have changed this Cl to Br, right? HOBr, HBrO2, HBRO, HBRO4. All halogens follow the same rule. The more the number of oxygens. So if you see acids that have several oxygens, and it says to arrange, look for the one that have more oxygens, the strongest. Then start reducing it from. Only one person does not follow this rule. And examiners like to set the outliers, the people that don't follow the rule. They are the ones that usually set. Everybody would have taken note of the follow, just like we did in organic chemistry, Markovnikov's rule and anti-Markovnikov's. Anti-Markovnikov's rule takes place in presence of peroxides. That one is what they want to just put peroxide there. In anti-Markovnikov's rule, the carbon that has the more hydrogen will take the halogen, while the carbon that has the less hydrogen will take the hydro. That's anti-Markovnikov's rule. So class, anytime you are reading, take note of the exception. Take note of the what? Exception. Look at all these people follow the rule. If you have more oxygen, you are stronger. But phosphorus containing oxo acids do not follow the rules. For phosphorus containing oxo acids, the more the number of oxygen, the weaker the acids. For phosphorus containing oxo acids, the more the number of oxygen, the weaker the. So H3PO2, H3PO3, and H3PO4. Based on what I just told you now, which is the strongest? H3PO2. Who is stronger? H3PO. So this one does not follow the rule. Normally, the person that has more oxygen should be stronger. Normally, the person that has more oxygen to be, but this guy does not follow the. Only phosphorus containing oxo acids don't follow the rule. So as the oxygen is increasing, the acid strength is reduced. As the oxygen is increasing, the acid strength is reducing. So phosphorus containing oxo acids do not follow the rule. Let's now look at strength of organic acids. Strength of organic. For organic acids, you know that organic acids must contain carbon, because for each kind of organic acid must be an organic compound, right? Organic compounds are compounds that contain carbon, right? You cannot be an organic acid if you do not have carbons. Class. If you are given carboxylic acid or alcohols, and you have to compare which is stronger, naturally carboxylic acids are stronger acids than alcohols. Carboxylic acids are stronger acids than what? Alcohols. But class, if you now look at only carboxylic acid, CH3COH, this CH3COH can undergo substitution reaction. Which one of the hydrogen is replaced with chlorine? So instead of H3, we have CH2, ClCOOH. When one hydrogen in CH3COH has been replaced with chlorine, you're now left with CH2, ClCOOH. If another hydrogen is replaced, we're going to have CH, Cl2, COO. And if all the three hydrogens have been replaced, we're going to have CCl3, CO. You can be asked to arrange all this acid in order of increasing strength. Class. Chlorine is called an electron withdrawing group. The chlorine is called what? And class. The more the number of electron withdrawing group in an organic acid, the stronger the acid. Follow me. The more the number of electron withdrawing group in an organic acid, the stronger the more the number of electron withdrawing group in an organic acid, the stronger the what? So, who is the strongest acid here? CCl3CO. So they arrange organic acids for you. In your exam now, don't go and cram it, you may go and put VR. Understand the concept, don't just cram that particular example only. Understand the cons. They give you organic acid, you see one person occurring more. This person that is an electron withdrawing group, therefore is a stronger acid. Don't forget, they cannot give you any type of example. They cannot just check chlorine to anybody. Chlorine is used there because chlorine is an electrophile in organic chemistry. Let's go back to organic chemistry a bit. Remember that only electrophiles are allowed to carry out those electrophilic attacks. So the more the number of this chlorine, other people that can be used is someone like bromine, is also an electrophile, can be used. So if you have to arrange, the more the number of chlorine, the stronger the acid. The more the number of chlorine, the stronger the what? Acid. Plus, we're going to stop here for today, so that tomorrow, please let me pause the video. Tomorrow we're going to continue from.
Pause or end.
Wait, leave it first. All right, so if you've stayed to the end of this class, we're going to continue the class tomorrow with pH, POH, buffer capacity, buffer solution, then go straight to thermodynamics or spontaneous chemical and physical changes. Then Friday will now be electrochemistry, which is the last topic of the course, electro. As it stands now, we just have little part of acid base remaining, then thermodynamics will be done tomorrow. Friday will be electro, and we're done with the course. Please, if you've not yet subscribed to our channel, I'm a student, I told you yesterday, hit the subscribe button, it's free, you're not paying to subscribe. Hit the subscribe button and subscribe to our channel. If you're watching this video, before you leave, hit the subscribe button. Alright, thank you very much. See you tomorrow by 12 p.m. Don't wait for me to post on the group. Stop it, yes.